Okay. All right. Good morning again, everyone. Shout out Trisha, Prince, John Christian, and Michael. Thank you for joining me today. Talagang paunti na ng paunti yung umaten ng synchronous classes, ano? Siguro I'll have okay, siguro I'll give some extra credits for you guys kasi sinamahan niyo ako pagbalik sa reading break. Kailangan ko pala 'tong i-screenshot para malaman ko. Sige, i-comment ko na lang muna. So, hindi, kayo na lang yung mag-comment. Comment niyo na lang yung pangalan ko tapos lagay niyo extra credit. Para 'pag binalikan ko yung convo natin or itong thread na 'to sa Teams, I'll be able to see it, okay? I don't know if I already announced that I already graded most of problem set number 1, though I haven't released the list of top notchers for the class kasi meron pang mga nag-request for late submissions due to some valid reasons. Hindi ko pa na-checkan yung mga work nila, nakatambak pa sa email ko. Pero sa Canvas, lahat ng nasa Canvas ay na-gradean ko na. So, kindly take a look at it and at least learn from it para yung mga comments ko, yung mga generic comments ko dun sa problem sets nyo ay ma-incorporate nyo sa mga susunod na problem set so you don't incur the same deductions later. Okay? So, okay, so that's it. And then, yeah, I hope you watched the recording, which I set the as your watching assignment, quote unquote, for Holy Tuesday last week. Yun yung latter part or yun yung last part na ng Unit 2, which talks about compact sets, the Heine-Borel theorem, which caps off Unit number 2, which is all about sequences, right? Tapos medyo kakaiba yun dun sa approach na ginawa natin sa Math 36 or sa Math 30 series. Kasi sa Math 30 series, sinimulan kayo sa limit ng function. Tapos yung sequences, kinonsider nyo na I think sa Math 38, which is the usual model for elementary calculus courses, okay? Pero dahil dito, medyo mature na kayo mathematically speaking, so sinimulan natin siya in a different and I think this is a more natural way of doing things. We start with the simple class of functions, which are sequences. Ito yung mga functions na ang domain ay the set of natural numbers lamang. And we investigated what is the limit of a sequence. Basically, it is the number to which the terms of the sequence approach as the subscript increases without bounds. So inimagine natin yung isang sequence to be an ordered listahan ng mga real numbers. Tapos ang limit ng sequence na yon ay yung number kung saan lumalapit yung mga exabends kapag ka yung mga n, yung mga subscript na n ay napakalaki na. And we're able to deduce several theorems, several results that help us to determine, number one, if a sequence is convergent or not, and number two, evaluate the limit of those sequences, all right, in different ways. We can decompose the function into the sequence into much simpler sequence, look at its subsequence, etc. So nagkakaroon tayo ng idea kung ano yung limit ng isang komplikadong sequence kung ito man ay nag-exist. All right? Now, yun yung simpleng klase ng mga functions. We are now ready to look at the more generic type of functions. Hindi na lang natin lilimitahan yung mga functions na hinahanapan natin ng limit or check natin kung nagko-converge. Dadalhin na natin siya dun sa mga functions na ang domain na ay yung set of real numbers. So basically, there is nothing much new with this unit. I think most of the results you've seen here ay nanggaling na sa Math 36. Ito yung chapter 1, I think, ng Math 36 nyo. Pero batch 18 kayo, ano? Tama ba? Or younger? So, bago na yung Math 36. Na-implement yung bagong Math 36 when I was already gone. Kaya hindi ko na saulado yung curriculum nun. But I think dito kayo nagsimula, right? Unit 1 nyo doon ay probably review of functions. Tapos, limits of functions na. You already you started, or actually the early part of 36 is for your dreaded epsilon delta definition. Tama ba? Alright? So kung tama yon, so titingnan lang natin, i-revisit natin siya. Pero ngayon, ang maganda, meron na tayong prior knowledge. Thank you, Michael, for responding. Ano yung prior knowledge natin? Alam na natin, meron na tayong alam about sequences, about limits of sequences. Now, we will bank on that and take advantage of those results para mas maintindihan o mas madaling ma-develop yung konsepto ng limit ng mga functions na ang domain ay hindi na lamang set of natural numbers. And that's what the entirety of unit number 3 is all about. Okay? So nothing much is new here. You have seen these results, pero we will look at it from a different perspective. So medyo siguro papalalimin lang natin ng konti kasi nga mas mature na kayo kesa nung nag-Math 36 kayo. All right? Now, here are the contents of unit number 3. Oh, by the way, guys, I hope it's okay. Tinigilan ko na yung paggagawa ng study guides. Kasi number 1, di ko naman siya nasusunod, right? So, and I think it's better if we keep the discussion free flowing, okay? And I think nobody in the class requested offline or asynchronous access. So, lahat kayo ay sumusunod sa synchronous schedule. So you don't really need the study guide, okay? Even if konti na lang yung umattend ng lecture, but I know some of your classmates are watching the recording at a much more convenient time for them, which is good. Kaya feeling ko hindi na masyadong kailangan yung study guide. And hindi naman natin nasusunod, ano? And mahirap yung lagi tayong conscious na mayroon tayong hinahabol na study guide. So let's just take it as ease and keep a laid back attitude in Math 155. So ito yung anim na sections nung unit. We'll take a look back at the definition of limits of functions, okay? And then yung sa section 2, i-integrate natin ano yung natutunan natin sa limits and sequences papunta sa limit ng mga functions, okay? How these two are related, okay? Actually, I think madadaanan na rin natin to sa section 3.1 because you will see na yung mga theorems ngayon sa limit ng isang function na ang domain ay R or subset ni R, not necessarily N, okay? Ay mas madali nang i-prove ngayon kasi pwede nating gamitin yung mga results natin from the discussion of limits of sequences. Yun yung kagandahan ng approach natin sa Math 155. Kasi hindi na tayo mag-work palagi or hindi natin kailangan palaging mag-work dun sa epsilon delta na definition and limit ng isang function. Okay? Kasi pwede ko siyang ibaba. Oops, what happened? Pwede ko siyang ibaba doon sa sequences kasi napakalaki ng overlap o napakatindi ng relationship between limits of functions and limit of sequences. Right? And then you see usual topics, continuity. Pero ngayon, after we talk about the basics of continuity, itatali uli natin yan dun sa konsepto ng compact sets, which is the last topic in section 2 or in unit 2. Okay? Tapos uniform continuity na. Tapos we will cap this unit off with one of the most fundamental and I think most useful result in calculus, or one of the most useful results in calculus, the intermediate value theorem. Okay? So siguro nung 36, binabrush off nyo lang yung IVT, pero lalo na yung mga estudyante ko rito sa 175, you see that IVT, as simple as this theorem looks, napakalaki, or despite its simple looks, napakalaki ng implication ng intermediate value theorem. Okay? So the unit is just 17 pages long, pero alam nyo naman, kahit siguro 5 pages yan, kaya kong daanin sa daldal yung unit, all right? But let's get started because our goal is to have the problem set after we do or after we finish unit 3. So the earlier we finish unit 3, the earlier the problem set would be. So I think it would be, we'll need siguro mga 2 weeks for unit 3. So expect that week after next week, we will be having our second problem set. Okay? Now, tingnan natin. So, limit ng isang function. Medyo kakaiba yung konsepto ng limits. It is not part of classical calculus the way Newton or Leibniz invented it, because if you go back to history, yung konsepto ng yung calculus ay naimbento siya in the 1600s. At least the formalism ng calculus na imbento noong 1600s by Newton and Leibniz independently. So they work differently. I think Newton is much more on the derivative side, and Leibniz, I think, started with the integral part, okay, and then they somewhat met in the middle, and people realized that their works are equivalent. They did it separately, but they got the same product, which is the calculus that we know right now. Okay, 1600s. Pero by that time, hindi formal yung yung konsepto ng limits, all right? Although there are some earlier mathematicians that sort of have this concept of limits and continuity, all right? Hindi siya na-formalize kagad kasabay ng derivatives and integrals, which is kind of absurd from our perspective kasi since natuto tayo ng calculus, una ay limit talaga. Tapos yung limit, ginamit siya para i-define yung derivative. Tapos yung limit, ginamit na naman para i-define yung integral. All right? And it's a little bit difficult to accept na historically, hindi nagamit yung konsepto ng limits and continuity when you're talking about derivatives and integrals, at least formally. Okay? Siguro at the back end, may konsepto ng limits na nagagamit pero hindi conscious yung mga mathematicians ng 1600s when they are doing calculus about the concept of limits. It's just in the 1820s that I think Bolzano, okay, first broached the idea of the epsilon delta definition for limits. So it took around 200 years or 2 centuries bago na develop yung konsepto ng limit. And if you think about that, that's a long time, all right? And we are now on a different paradigm na una talaga yung limit, tapos derivatives, tapos integrals, all right? So one reason behind that is in the 1600s, people don't consider discontinuous functions, all right? So ang mga functions lang nilang kino-consider nung mga 1600s ay mga functions that can be drawn, whose graphs can be drawn without lifting your pen. So there's really no need to discuss continuity or to discuss limits of functions for that matter. Okay, it's just that Bolzano developed the epsilon delta definition, and then I think it was Cauchy who said na, or who gave our modern idea of continuity. Kasi dati continuity kaya mo lang yung i-drawing ng tuloy-tuloy, kaya continuous yung tawag. Kaya mong i-drawing yung graph without lifting your pen. That's a continuous function, all right? Sabi ni Cauchy, lagyan natin yan ng isang mathematical criterion. Okay? Kasi na-realize nila noong 1800s, meron pala mga functions na nagagamit sa tunay na buhay na hindi discontinuous or whose graphs cannot be drawn without lifting your pen. So kailangan na magkaroon ng magkaroon ng distinction between the two. And Cauchy said, a function is continuous if an infinitesimal change in the x value will cause an infinitesimal change in the y value. Okay? When we say infinitesimal, napakaliit. So siya yung kabaligtaran ng infinite, all right? So sabi niya, pag may maliit na pagbabago sa x, dapat yung pagbabago sa y ay maliit din. And that's the central concept behind continuity as proposed by Cauchy. And we will look at these developments later. Okay? But of course, let's look at limits of functions first. Okay? Now, some preliminary things here kasi kailanganin natin to in the course of our discussions. Towards the end of unit number 2, we gave a characterization for limit points. Remember, ang definition natin ng limit points, ang isang number x ay limit point ng isang, okay, palitan ko lang yung color ng pen. Okay, now we said that a number x is a limit point of a set A, all right? So A prime, yun yung derived set ni A, set of all limit points. If and only if, okay, for all epsilon greater than 0, the epsilon neighborhood around X intersection the set A less the set X is non-empty. All right? So ito yung definition natin ng limit point. Ang isang number ay limit point ng isang set kung lahat ng epsilon neighborhood around X ay may laman na iba pang member ni A aside from X itself, right? So ibig sabihin, nagkukumpul-kumpulan yung mga elements ni A sa paligid ni A. Kasi kahit anong gaano kaliit na neighborhood, containing X or neighborhood ni X, lagi yung may laman na kapitbahay na nanggagaling kay set A. All right? So yun yung sinasabi natin na limit point. And towards the end of unit number 2, we gave a more operational description about limit points. We said that limit points can be characterized this way in terms of limits of sequences. All right? We said that the number C is a limit point of a set A if and only if C ay limit ng isang sequence na nagko-contain kay A na hindi term C. Okay? So ito yung, hindi ko alam kung na-prove natin to sa dulo ng Unit 2 or pinanood nyo na lang to dun sa video recording. Pero kaya ang tawag sa kanya ay limit point. Kaya ang tawag sa kanya ay limit ng isang sequence. O kaya dun sa limit point, bakit siya tinawag na limit point? You might be thinking that the term limit is used coincidentally para sa isang limit point and para sa limit ng isang sequence. But there are little coincidences in terminologies in math. Usually, kapag meron kang isang term sa math, may dahilan kung bakit yun yung tawag. All right? There is a close relationship between limit points and limits of sequences kasi nga sabi natin ang isang number or towards the end of Unit 2, sinabi natin na ang isang number ay limit point ng isang set kapag merong isang sequence doon sa set na yon na nagko-converge doon kay point C. All right? And that's a nice thing. All right? Kasi mas operational itong definition ng isang limit point. Then, what else? Okay. And then, intuitively, ito yung nakita natin sa Math 36. Kapag meron kang isang number C sa domain ng isang function f, all right? Or actually, hindi nga domain yung sinabi natin sa Math 36. Sinimulan natin yung kapag meron kang function, tapos merong isang open interval kung saan defined yung function f, kumuha ka ng isang number doon. Ang limit ng isang function, okay, intuitively, ay equal dun sa number kung saan palapit ng palapit yung mga function values habang yung mga x's palapit ng palapit kay C. So this quantity is used to describe the behavior of the function values f of x as x approaches the number C. Ano yung nangyayari kay f of x habang yung mga x palapit ng palapit kay C? Yun yung tinatawag natin na limit ng isang function. But again, there's a little problem with that notion. Sa math, hindi tayo pumapayag na may ambiguities. So dapat meron tayong operational definition para sa limits. Even though, kung isipin nyo, parang ang simple-simple nito, yung limit ng f of x approaches C ay yung number na nilalapitan ng mga f of x habang yung mga x's palapit ng palapit kay C. But the question is, how malapit is malapit? All right? Yun yung gusto nating i-quantify. Kasi nga, that might lead to some ambiguities. And we don't want ambiguities in mathematics. So what, I forgot who proposed this, but I think it was Bozano who proposed this epsilon delta definition for the limit of a function in the form of a challenge and response, which is basically in the same vein as how we define limits of sequences. Dun sa limit of sequences, lagi tayong may challenge na epsilon. Ang goal natin mahanap yung starting index capital N. Now, in definition 3.1, we will define the limit to be, we will use a challenge response sort of definition para sa limit ng isang function in such a way that we are issuing a challenge epsilon and the goal is to find a number delta. And as I've mentioned before, we usually use epsilon and delta in math to denote very small positive quantities. All right? So ito na yung konsepto ng closer and closer na ginamit natin dun sa intuitive notion. Okay? Gumagamit tayo ng epsilon and delta because these two guys are just small numbers or our mathematical conventions for very small numbers. Okay? Now, ano yung challenge response definition? That's in definition 3.1. So here we consider a function f whose domain now is not just n, but an arbitrary subset of R. Okay, so tawagin natin A. Yung domain ni f ay si A, which is a subset of R, and we will let C be a limit point in the set A. Okay, then we say that the limit of f of x as x approaches c is equal to L. Oh, what's happening? Yeah, my Google Drive is keep on popping up. I don't know why. Okay, so the limit is equal to this guy if and only if for any epsilon that is issued. We can always find a response delta greater than 0 such that whenever x is within delta units away from c, okay, with x being in A, it follows that f of x is within epsilon units away from L. Okay? So ito yung gusto nating mapakita. Alright? So pag binigyan tayo ng isang epsilon na greater than 0, kailangan nating humanap ng delta na greater than 0 such that whenever this is true, we are guaranteed that this will follow. Okay, yung kapag totoo yung delta inequality, dapat mag-hold yung epsilon inequality. Right? So ito yung tinatawag na ating epsilon delta, which is not very different from what you had in Math 36. Can anybody point out to me ano yung pinagkaiba nito? Kung tandaan niyo pa yung epsilon delta definition sa Math 36, ano yung pinagkaiba nito dun sa Math 36 version? And then we will discuss ano yung implication ng pagbabago na yon. Or kinalimutan nyo na yung epsilon delta mula sa Math 36? Anyone? Come on, guys. Ano yung pinagkaiba ng definition 3.1 mula dun sa nakita nyo bang gamit sa Math 36? Napapaghalataan tuloy ang edad, ano? So, light-old kasi yung gamit namin ng undergrad and when I started teaching. I don't know kung yun pa rin yung gamit nyo. Di nyo natanda? Okay, actually, it is in the preamble ng definition, okay? Ano yung preamble natin sa definition 3.1? It says that the function f has domain A and the number C at which we are looking at which we are evaluating the limit at, right, should be a limit point in A. In Math 36, you will not see the same preamble. Kasi hindi pwedeng gamitin itong definition na to kasi wala pang konsepto ng limit point sa Math 36. Ano yung sinabi sa Math 36? Ang sabi sa Math 36, let f be a function defined in some open interval containing c except possibly at c. All right? So, yung definition niya sa Math 36, again, sulat natin yan. Yung Math 36 version, ang sinabi ron ay let f be defined in some open interval containing c except possibly at c. And you will see how limiting that preamble is. Kasi dito, kailangan makahanap ka muna ng isang open interval na nagko-contain kay C kung saan defined yung function mo all throughout. Okay? But in this particular case, in our definition right now, we are allowing a more broad class of functions na ma-define na natin ng limit. Kasi hindi natin kailangan si function f ay maging defined sa isang open interval na nagko-contain kay C. Kailangan lamang defined siya sa isang set A kung saan limit point nung set na yon si C. But let's give a specific illustration for that implication, all right? Now, tingnan natin yung ano ba magandang function? Square root of x. Y equals square root of x. Anong sabi niyo dati sa limit ng square root of x as x approaches 0? Sige, yan nga. Dapat tandaan niyo pa yan, ha? Ano yung sabi niyo sa Math 36? When you considered the square root function and you look at the behavior as x approaches 0. I think this is the classic example nung Math 36. So anong sinabi niyo nung araw about this guy? With respect to limits. Hello guys, andyan pa ba kayo? Paggalawin niyo ng konti yung baso, ano? Okay, thank you, Christian. Sinabi niyo dati sa Math 36, the limit does not exist. Bakit? Bakit niyo nasabi yan? Or bakit napwersa kayo na sabihin yung conclusion na yon na hindi nag-exist yung limit? Even before you talk about the limit from the left and limit from the right. I think this is one classic example na sinabi na, oops, hindi mo pwedeng i-define, or hindi natin yan pwedeng kunan ng limit kasi hindi niya nasa-satisfy yung preamble ng definition ng limit sa Math 36. Anong sabi? Dapat muna si F maging defined sa isang open interval containing the number C. In this example, our number C is 0. Okay? So, when we rephrase the preamble of the Math 36 limit definition, it will require that the square root function to be defined in some open interval containing 0 except possibly at 0. Okay? But if you draw any open interval around 0 or containing 0, lagi siyang may makukuhang part na nasa kaliwa na ng y-axis. So ibig sabihin, it will include any open interval containing 0 will include negative numbers. And the square root function is not defined for negative numbers. So kaya nyo sinabi sa Math 36 on limit does not exist na lamang kasi hindi nyo na-satisfy yung preamble ng definition. But I think that's a little off technically, all right? Kasi hindi sinabi ng definition na hindi na nag-exist yung limit. Ang sinabi lang ng definition, ito yung definition kapag ka yung function f ay defined sa isang open interval containing c except possibly at c. Hindi na satisfy yon nung square root function at 0, so hindi natin pwedeng gamitin yung definition ng Math 36 para makonclude ano yung limit ng square root of x as x approaches 0. There should be a bigger definition of limits that should be applied in order to conclude what this is. And dun sa subsequent chapter ng Math 36, sinabi nyo na mag-exist lang yung limit kapag ka yung limit from the left and the limit from the right agree from each other. Okay? And I think that's when it is properly apt to conclude that this limit doesn't exist kasi iba yung limit from the left and yung limit from the right. Okay? Pero titingnan natin siya ngayon sa isang mas generic na, yung definition natin ngayon ay mas generic. Kasi hindi natin kailangang humanap ng isang open interval na nagko-contain kay number C. Now, ano yung requirement lamang? Yung function ay defined sa isang set A kung saan limit point yung number C. Okay? So here, our domain is the open interval 0 to positive infinity. All right? So yan yung set A natin. And obviously, the 0 ay limit point ng A. So note that 0 is a limit point of A. Kasi makakahanap tayo ng isang sequence, all right, na nagko-converge kay 0. Specifically, yung sequence 1 over n ay nagko-converge kay 0. Ito ay isang sequence properly contained in A whose terms are not equal to 0 and yet this will converge to 0. So by the characterization of limit points, dahil mayroong isang sequence doon sa loob ni A na nagko-converge kay 0, ibig sabihin si 0 ay isang limit point. If you're not comfortable using that, you can go back to the definition ng limit point. Mag-drawing ka dyan ng kahit anong epsilon neighborhood. Gaano man yung kaliit, it will contain infinitely many elements of the set A. Okay? So kaya indeed si 0 ay limit point ng set A natin. Okay? So dahil siya isang limit point, okay? Or another way to look at it, baka mas computational yung aspect, yung thinking nyo. Another way to think about that or to prove that 0 is a limit point of A is to note this guy. This is a closed interval. Or kunin mo yung A prime. Yung A prime ay yung derived set ni A ay yung smallest closed set containing A. But A itself is a closed set. So ibig sabihin, lahat ng laman ni set A ay limit point kasi nga siya ay isang closed set. Or, tama nga ba yun? Alam may butas dun sa sinabi ko na yan. But essentially, you can look at, you can use the definition to say that 0 is a limit point of A. So dahil si 0 ay limit point ni A, so papasok or pwede nating i-consider si square root of x under definition 3.1. And that is something that we could not do in the math36 definition ng limit ng isang function. That's why definition 3.1 is much more generic than what we use to study in Math 36. Okay? But before probing deeper into the use of definition 3.1, its implications and its advantages over the version in Math 36, let's look back at several examples paano nga ba ginagamit yung epsilon delta response sa pagpo-prove ng limit ng isang function. And this is something that I guess everyone dreaded no undergraduate, all right? Especially Math 36, freshman year, baon niyo yung pride na, nag-BS math ako, magaling ako sa math, so dapat sisiw lang sa akin yung mga math courses. But you are not given equations to solve sa unan yung math course, pero ang binigay, prove that the limit of 2x minus 3 as x approaches 4 ay equal kay 5. Tapos yun na, bumaba na yung self-esteem nyo, right? That's fine. Believe me, that happens to everyone, all right? Ganun din yung nangyari sa akin nung undergrad. Ang yabang-yabang ko. Magaling ako sa math nung high school. Nag-MTAP ako nung araw. Tapos, MTAP na nga ba tawag sa amin nun? Parang MTAP na rin ang tawag sa amin nun. So, edi mag-BBS math ako kasi magaling ako sa math. And then, Math 36 came, all right? Tanda ko, bagsak ako sa unang exam ko ng Math 36. Bagsak nga ba ako doon? Yeah, I think bagsak ako sa limits. And now thinking about it, napakasimple ng limits. Bakit ko binagsak yung long exam ko sa limits, alright? Kasi naman ganito yung binigay. And I think we are lacking maturity, mathematical maturity nung mga panahon nag-Math 36 tayo, right? Because we're not used to proving, okay? Pero yun yung unang mga set of examples sa Math 36. But I guess you have little advantage kasi medyo 2 years older na kayo nung nag-college kayo, kasi hindi pa kami K-12 nun. But anyway, so let's see. Example 3.1. Pakita natin yung limit ng 2x minus 3 as x approaches 4 ay equal kay 5. Intuitively, titingnan lang natin ano yung nangyayari sa mga function values 2x minus 3 habang si x palapit ng palapit kay 4. So what you could have done, if you're more on the empirical side, pwede mag-plug in ka ng mga x's na napakalapit kay 4. Say 3.999, 3.9999999, and so on. Tingnan mo saan palapit ng palapit yung function values. Also try to plug in 4.01, 4.001, and then 4.000001, and observe the behavior of the function values 2x minus 3. And you will see that in all of those tests, laging palapit ng palapit kay 5 yung sagot habang yung x palapit ng palapit kay 4. Right? So that could have been enough to say na mukhang yung limit ay equal kay 5, but that is not sufficient to show that indeed the limit is equal to 5. Because we want to show or establish that if we make x arbitrarily close to 4, then 2x minus 3 will be arbitrarily close to the number 5. And that's what the epsilon delta challenge is all about. So pag binigyan tayo ng epsilon, dapat makahanap tayo ng delta na kapag ka itong inequality na to, absolute value of x minus c is between 0 and delta, then itong epsilon inequality, f of x minus the purported limit must be less than epsilon or must have absolute value less than epsilon. Okay? So pag binigyan tayo ng epsilon, ano yung delta? Pero syempre, may hirap malaman ano yung delta kaagad. Alright? Parang sa sequences lang. Sa sequences, bibigyan tayo ng epsilon, hanapin natin yung starting index capital N. Pero hindi siya madaling isipin right away, so kailangan natin ng preliminary analysis. So we can do the same thing para hanapin yung delta na sagot dun sa kahit anong epsilon na ibibigay. Alright? So simulan natin with the preliminary analysis. So kailangan, bibigyan tayo ng epsilon. Kailangan natin maghanap ng delta. Okay. Now, ano yung kailangan masatisfy? Dapat, kapag itong inequality na to ay totoo, yung absolute value ng x minus 4 ay between 0 and delta, then dapat itong f of x minus L ay less than epsilon. So we are sort of working backwards here. We'll start with what we want to achieve and find a condition on delta such that this inequality will be forced to hold. Okay? So start ako dito, working backwards. Start with the goal and then reconstruct the delta. Now, I'll start with this f of x minus L less than epsilon. And then the goal is to express the left-hand side to a form similar to the delta or to the left-hand side of the delta inequality para magamit natin para ma-relate natin yung delta at saka yung epsilon together. So yung f of x minus L, kailangan mong masulat na malapit dun sa x minus c. Alright? So pag sinimplify ko to, tingnan natin, magiging 2x minus 8 yan. And again, gusto ko tong left-hand side nito masulat na kamuka noong nasa delta. Okay? And that's not hard to do for this example. We just need to factor out 2 from the absolute value. So ilabas mo yung 2, magkakaroon ka nito, which is perfect because I know that this is bounded by delta. So mangyayari, ito ay magiging 2, tapos alam ko to ay mababound ng delta less than epsilon. Okay? Saan ko to nakuha? Kasi yung x minus 4 ay later i-assume natin na mas maliit kay delta. Okay? And we want this guy to be less than epsilon. Ano dapat yung delta para itong guy na to ay maging mas maliit kay epsilon? Pero alam ko na yung x minus 4 hindi lalampas ng delta. Alright? So, ibig sabihin, kung siya hindi lalampas ng delta, then yung 2 times absolute value ng x minus 4 ay hindi lalampas ng 2 delta. But I want to force that this guy will be less than epsilon. So what I can do to force that inequality ay persahin na yung mas malaking number kesa dito ay dapat mas maliit kay epsilon. And that's why I will impose the condition that 2 delta should not exceed epsilon. Because if that will hold, then that means 2 times x minus 4 will be forced to be less than epsilon. Okay? And that's the reason why I want to write the absolute value of f of x minus L into a form, right, that involves absolute value of x minus c. Because I can just replace that factor x minus c by delta. Okay? Tapos from this inequality here, I can conclude that delta can be chosen as any number that is less than epsilon over 2. So sinasabi dito, piliin mo yung delta to be any number na mas maliit dun sa challenge na epsilon over 2. Okay? And essentially, if you do that, then everything will fall into the proper places. Now, let's take a look at the formal proof. Okay? Kasi dun sa prelim analysis, nakita na natin ano yung delta na magiging sagot dun sa ibibigay na epsilon. Now, when you write the formal proof, so you'll just take epsilon to be greater than 0, issue the challenge, and then gamitin nyo yung delta na nakuha natin doon sa prelim analysis. Or actually, ito pala ay pwede natin pilihan to be less than or equal to, but it doesn't matter. Tanggalin nyo man yung equality or hindi. But I actually prefer less than, pero hindi naman siya malaking issue dito kasi or naman yung connective. Pwede nyo siyang tanggalin anytime. Or actually, pwede nyo siyang idagdag anytime. Okay. Now, kung ito yung challenge epsilon, nakita na natin na an appropriate response is any number less than or equal to epsilon over 2. Okay. So, sinabi ko na dito sa proof, okay, kung yan yung epsilon mo, ang delta ko ay kalahati ng epsilon na ibibigay mo. And from here, we want to establish the epsilon inequality. So, how do we do that? Assumption dun sa definition yung delta inequality. So, we always begin with the absolute value of x minus 4 being between 0 and delta, okay? But we said that delta is equal to epsilon over 2 or is a number less than epsilon over 2, then we'll be forced that this guy Ito na pala, nakasulat na siya, less than epsilon over 2. Tapos, kailangan kong makuha yung epsilon inequality, right? So, kailangan ko itong i-manipulate para makuha ko yung epsilon inequality. Specifically, the left-hand side should be absolute value of f of x minus L. Pero nakita na natin sa prelim analysis kung paano yung x minus c ay related sa f of x minus L. So remember, to write f of x minus L into a form that involves x minus c, we needed to factor out the 2. All right? So ngayon, kabaligtaran yung gagawin natin. So nagmula ako dito sa delta inequality. Ang gagawin ko ngayon, mag-multiply ako ng 2 both sides. And I will get this guy. Right? And then manipulate this guy until you get here, f of x minus L less than epsilon. So what we have shown here is that whatever epsilon is given, we can find a delta. Specifically, we can use delta to be epsilon over 2, such that if this inequality is true, then this will follow. Okay? And that is indeed the definition of being the limit. So indeed, the limit of f of x as x approaches 4 ay equal kay 5. All right? So any questions with that, guys? Hold on a minute. So everything clear? Or you are haunted by memories of the past? Ito yung ayaw na ayaw natin sa Math 36, ano? So let's see one more example. Now, example 3.2. Okay. So ngayon naman, tingnan natin yung x squared plus x taken as a function whose domain is this half closed, half open interval 0 to 1. And we need to prove that the limit is equal to 2 as x approach 1. Okay. Tapos, prelim analysis ulit tayo mag-start. Okay. So prelim analysis will be working backwards. So we will work with absolute value of f of x minus L less than epsilon. And we want to show, we want to look at the relation between delta and epsilon. Okay. Now, i-expand ko muna yung absolute value ng f of x minus L. So this will be x squared plus x. Okay, that's f of x. Then the supposed limit is 2, so minus 2. All right. And then again, the goal is to write this expression into something that involves absolute value of x minus c. Our c here is 1. So kailangan by hook or by crook, I'll write this guy na merong absolute value of x minus 1. And I guess here we have limited options, which is good kasi konti lang yung pwede nating i-try or tricks na pwede nating i-employ. In this particular case, we can factor this guy and write it as x what? X plus 2 times x minus 1. All right? Then why do I want to have this? Because if we have that, then remember dun sa proof, our assumption is the delta inequality. Okay? So ibig sabihin, by the delta inequality, we'll be sure that the absolute value of x minus 1 will be less than delta. So I can replace the absolute value of x minus 1 by delta. Tapos kung ano man yung upper bound na to, para dun sa expression absolute value of f of x minus L, ifo-force ko lang na ito ay less than epsilon. So ifo-force ko siya na mangyari. Now, we're in a bit of a pickle here kasi okay, na-bound ko na yung absolute value of x minus 1, but how do I take care of the other factor? Okay? Kasi hindi ko alam kung paano nagbe-behave yung x plus 2 right away. Unlike absolute value of x minus 1, which I know later will be assumed to be less than whatever delta that we will choose. Okay, so yun yung medyo problema rito. Now, one way to do this is to go back to the domain. Okay, so dito ang usapan lang natin ay mga x's na nandito sa interval 0 to 1. So that means the x's that we are considering here satisfy this inequality. x less than 1. Tama? So kasi yun lang yung domain natin. So ang usapan lang, dapat yung mga x's na kinoconsider natin ay nandoon sa loob ng set A, which is the closed the half-closed, half-open interval 0 to 1. So this is the case. And note, what I want to see is how the absolute value of x plus 2 behaves. I know how x behaves. All x's are between 0 and 1, 0 included. So all I need to do is to look at what happens to x plus 2. Now that's easy. I just need to add 2 to all sides of the continued inequality. So we'll have 2 less than or equal to x plus 2 less than 3. All right, addition property of inequality. And from here, we can deduce that the absolute value of x plus 2 is less than 3. Okay? So, ibig sabihin, pwede kong palitan yung absolute value of x plus 2 that we have here by 3, and what I get is a larger number. So, basically, this guy is bounded above by 3 times delta. But remember, in the definition, we want this guy to be less than epsilon. Ang alam ko lang, ito ay mas maliit kay 3 delta. Tapos ito, gusto ko maging mas maliit kay epsilon. Now, what I can do is to force that 3 delta must be less than epsilon. Because if I will do so, kung i-require ko yung 3 delta ay mas maliit sa epsilon, then automatically this guy will be less than epsilon. Okay? In this particular case, we can choose delta. Lagyan natin, pwede pa lang less than or equal to para lang maging katulad siya nung nandun sa notes. So I can choose delta to be any number less than or equal to epsilon over 3. Okay? So ito yung magyayabang na kayo dun sa proof, alright? Dun sa formal proof. Dun kasi sa formal proof, pwedeng hindi nyo na isama yung prelim analysis. So pag nagpa-problem set ako, pag hindi ko sinabi na isama yung prelim analysis, pwedeng hindi nyo na isama yung prelim analysis. Pwedeng magsimula na kayo sa given, sir, any epsilon of your choosing. I have a delta, which is epsilon over 3. Okay? So, pwedeng doon na kayo mag-start. Pag hindi ko hinanap yung prelim analysis, pero pag sa problem set, hinanap ko yung prelim analysis, then hanapin ko yung prelim analysis. The advantage of doing a prelim analysis or including the prelim analysis in problem sets or homeworks, makikita ko pwede ko kayong bigyan ng partial credit in case your choice of delta is wrong. Okay? Tapos, pabaligtad na ngayon yung gagawin natin. Okay? Now, paano pabaligtad? Okay, write your assumption. Our assumption here is the delta inequality. So that means absolute value of x minus 1 is between 0 and delta will be part of the assumptions in order to establish the epsilon inequality. And then another thing is that x's belong to 0, 1. Alam ko na gagamitin ko yon kasi dun sa prelim analysis, ginamit ko siya dito. Okay, so you can insert some things here. Okay, pwedeng lagyan mo na yan ng period. Tapos pwede mo sabihin dito, moreover, absolute value of x plus, what was that? X plus 2 is less than 3. Pwede mo nang i-prepare yon galing dun sa prelim analysis. Nanggaling lang naman yon dito sa inequality na to. If you want to make pasikat na sir, kaya kung ilagay lahat ng detalye, kung gaano makadetalyado yung gusto mo sa sagot ko, pwede nyo isama tong inequality na to. So you can say, starting from here, I can show that I can deduce the following facts. All right? And then, pag meron ka na nito, all right, I think all of the ingredients are ready to establish the epsilon inequality. So start ka sa f of x minus the purported limit, equals siya dito, expansion. And then nakita natin, ang ginawa natin sa prelim analysis, nag-factoring lang naman tayo. Alright? Tapos dito na papasok yung main ingredients ng ating proof, right? So we know that that absolute value of x minus 1 is less than delta, so I can replace it by delta. And then we know that absolute value of x plus 2 is less than 3. So this guy was replaced by 3, okay? And we replace these two factors by larger numbers, so the product will be larger, okay? So that's guy works that way. Tapos, ang delta, pinili natin to be epsilon over 3. So we'll have 3 times 3 times epsilon over 3. That's going to be epsilon. So basically what we have shown here is that given a challenge epsilon, we have a response delta such that absolute value of f of x minus L is less than epsilon. All right? So, yeah. Ito yung isang case na okay, kailangan nating balikan ano yung domain na binigay. Okay, kasi nga merong isang factor na hindi natin sure right away kung ano yung upper bound para sa kanya. All right. Now, this will not always work, especially if your domain is not bounded. Okay? Okay to kasi bounded yung domain. So ibig sabihin yung x, lagi kang may inequality involving x. And then you can easily manipulate that inequality like in this manner, okay? Para makuha yung anuman yung upper bound na kulang dun sa analysis, all right? Pero kapag ka unbounded yung interval, medyo mahirap nang pumili. Halimbawa, limit ng x squared as x approaches 3. Gusto natin i-prove na yan ay equal kay 9. Okay? So, we can carry on with the usual prelim analysis that we have. Okay? Epsilon. Okay? Tapos alam ko to ay, ito yung magiging part ng assumption. So, ang goal ko rito ay masulat yung f of x minus L into a form that involves absolute value of x minus 3. But if I do that, I will see a problem. A problem will arise. So I'll have this. Yan yung f of x minus L. Sulat ko raw yan na merong absolute value ng x minus 3. So again, I don't have much options here. So all I can do is to factor this out as this guy, right? And this is good. I can just replace it by delta. Okay. Ang problema ko ay ito. Absolute value of x plus 3. Dun sa problem, hindi binigay kung ano yung domain ng function. Binigay lang siya ang x squared. Kapag ka hindi given yung domain sa problem, i-assume natin na ang domain niya ay yung pinakamalaking set na posible. Right? Na walang magiging algebraic or mathematical problems. Dahil x squared yan, polynomial yan, kahit anong value ni x, kahit anong real number na value ni x ay pwedeng ma-plug in kay x squared. So that means we will choose the largest possible set na define yung x squared, and that will be the set of real numbers. And that's quite problematic kasi ngayon, kulang ako ng info. I don't have an info about the absolute value of x plus 3. Hindi ko magagamit yung trick na ginawa natin sa previous example na kunin yung inequality na magmumula dun sa domain. Kasi si x ay real number. So x can be very, very large. X can be very, very small, a very small negative number. So wala tayong inequality na katulad nung kanina. All right. Now, ano yung gagawin, sir, kapag ganyan? Well, dito pwede nyong i-restrict yung consideration into very, very small intervals. Okay? Kasi nga sa konsepto ng limits, mas concerned lang tayo habang yung mga x's palapit ng palapit doon sa number C. Okay? Hindi natin concern ano yung nangyayari habang malayo yung excess doon sa number na C. I don't know what's happening. Okay, so yun yung kaso rito. So ang ini-investigate lang natin ay habang yung mga x's ay palapit ng palapit kay C. We don't care about x's right here kasi malayo pa yan. Kaya nga ang base natin dun sa limit notation, the limit of f of x as x approaches C. So ibig sabihin na ang concern lang natin yung mga x's na super lapit na kay C. Okay? For that reason, we can say, ignore those numbers that are very, very far from, or that are not that very, very close to the number C, because all that matters are the numbers that are very, very close to C. Right? So in this particular case, I can choose, paano siya sinulat dito? Okay, Now, gusto ko ay napakaliliit na nila. All right? So that means I can just consider x's that are, say, within 1 unit away from the number c, which is C3 dito. Okay? So, pwede kong i-consider yung mga x's na super lapit na kay 3. Right? So, you can choose any number. So, basically here, maybe we can restrict our consideration to x's such that the absolute value or the distance between x and 3 is less than, say, 1. You can pick any number you want over here. Okay, kayo na yung bahala dyan. Pwedeng 1/2, pwedeng 1/4, pwedeng 100, pwedeng 1,000. Yung right-hand side na yan, siya lang yung sinasabi, ano yung mga excess na kinoconsider mo. Kasi again, sa limits, ang kinoconsider lang natin, ang prime consideration ay sa mga excess na napakalapit na kay C. Alright? So you can define how malapit is malapit for you. Pwedeng sa akin, malapit na yung 1. Okay? Pwede sa inyo, malapit pa rin yung 2. Pwedeng malapit pa rin yung 3. Malapit pa rin yung 4. And so on. So it's up to you to choose. Actually, you can make this any number that you like. Okay? But the common choice is 1. Alright? So i-consider mo lang yung 1 na distance. So ibig sabihin, kinukulong mo lang yung sarili mo sa isang 1 neighborhood around 3. So that's gonna be from 2 until 4. Okay? Tapos, ikukulong ko na yung mga excess doon sa interval na yon, and then I'll get an information about the absolute value of x plus 3. Alright? So, analytically speaking, makukuha ko siya dito by writing it as a continued inequality. So this would be -1 less than x minus 3 less than 1. And then remember, the missing info is about x plus 3 or the absolute value of x plus 3. So how do I make it x plus 3? I'll just need to add 6 to all sides. Pag nag-add ako ng 6 sa lahat ng sides, this will be 5. X plus 3 plus 6, that's going to be x plus 3. And then this would be 7. Okay? So x plus 3 is between 5 and 7. So that means the absolute value of x plus 3 is less than 7. Okay? Now, how do we get there? Pwede nyo kasi ditong idagdag yung -7. -7 is less than x plus 3, which is less than 7. So pag kinuha mo to, eto, at saka eto, boom, you'll get the absolute inequality over here. Okay? And that's fine because now we have an info about the absolute value of x plus 3. So eto pala ay marirestrict by 7 provided we are choosing our x's to be less than 1 unit away from 3. So we just need to take a look at take note of this na meron tayong restriction na in-impose para mag-work yung inequality na to. Para mag-work itong inequality na to. Okay? Ano yung condition nating in-impose? In-impose natin na yung absolute value of x minus 3 ay less than 1. Okay? Now, so yun yung mangyayari. So finally, kailangan kong i-force na ito ay maging less than epsilon. Alright? To guarantee that this guy will be less than epsilon, I will force that 7 delta is bounded above by epsilon, and that tells us that we can choose delta to be smaller than epsilon over 7. Or we will be forcing ourselves to choose delta to be smaller than epsilon over 7. But that will not be our final choice for delta because, again, we introduce an inherent or we introduce an outside assumption here. In-assume natin na yung absolute value ng x minus 3 ay less than 1. Tapos dun sa proof, i-assume natin ang absolute value of x minus 3 ay less than delta. Okay? So, ibig sabihin, dapat yung absolute value ng x minus 3 ay mas maliit dapat sa 1 at saka kay delta. Okay. So, ibig sabihin, nawala dito yung over 7. So that means I should choose delta to be the smaller between 1 and epsilon over 7. Bakit ko gusto yon? Kailangan ko na yung delta ay mas maliit sa 1 at saka kay epsilon over 7 para mag-guarantee na yung absolute value ng x minus 3 ay maging less than 1 mamaya dun sa final proof. Okay? So tingnan natin kung ano yung implication. Bakit ko kailangan kunin yung minimum, all right? Kunin yung minimum ng 1 at saka epsilon over 7. Okay? Tingnan niyo yung proof dito. Parang napakatalino na ng proof, no? Kasi sinabi niya lang epsilon greater than 0. Ang sagot ko dun sa epsilon na yon, the smaller between 1 and epsilon over 7. If you haven't seen the prelim analysis, then you'll be astounded by, paano nakuha yung paano nakuha yung delta? Bakit yung minimum between 1 and epsilon over 7? Pero kung binalikan niyo yung prelim analysis, all of the steps hopefully make sense. All right? Now, tingnan natin paano to mag-work. Well, always part ng assumption nung definition ay dapat yung absolute value ng x minus c is between 0 and delta. So we'll start with that, okay? And then remember that delta is the smaller between 1 and epsilon over 7. Yung may epsilon, gagamitin ko na yan mamaya dun sa para makuha yung epsilon inequality, all right? So I'll need to take care of the 1 first. So this is our assumption, okay? But since delta is chosen to be the smaller between 1 and epsilon over 7, then we are sure that the absolute value of x minus 3 is smaller than 1. Kasi yung delta ay yung mas maliit sa dalawa. So ibig sabihin, yung x minus 3 being smaller than delta will be smaller than both 1 and epsilon over 7. And so we'll get this. And I'm happy that I can properly use this kasi ito yung kinailangan natin mula dun sa prelim analysis. Tama? So napalabas ko na yan. So ibig sabihin mula rito, I can use the same manipulations as what we have done in the prelim analysis to come up with x plus 3 having an absolute value less than 7. Okay? So nasa atin na lahat ng ingredients, alright? So meron ako nito, meron ako nito. So all that is left to be done ay isulat yung f of x minus L. At ipakita yung epsilon inequality. So this would be x squared minus 9, but we know that this is x minus 3 times x plus 3. Nakita natin yan sa prelim analysis na yan yung ginawa. So we're just working backwards here. Okay? And then we know that absolute value of x minus 3 is less than delta by the assumption. Okay. And x plus 3 is known to be less than 7 from the choice of delta that we have, all right? But this guy is equal to epsilon over 7 times 7, so that's less than epsilon. And that ends the proof, all right? So indeed, the limit of x squared as x approaches 3 is equal to 9. All right. So any questions with that? I think. Sige, any questions muna? Habang nag-isip kayo ng question, 3-minute break muna tayo. So wala ba kayong gustong i-share, gustong i-chismis or something? Habang nagbe-break tayo for 3 minutes. Okay, bumabalik na ba yung mga pinagagawa niya sa Math 36? I think this is the opportunity para ma-appreciate niyo yung pinagagawa niyo sa 36. Kasi nung Math 36, parang ginagawa lang natin siya mechanically, right? Nakita natin sa slides ng teacher natin na ito yung proof, gagayahin ko lang siya. Or ipapattern ko lang yung gagawin ko dun sa ginawa niya. And without necessarily understanding what was that. And I was guilty of that. Alright? Nung Math 36 pina-pattern ko lang yan. Kaya pag medyo naiba ng konti yung binigay ng teacher ko, hindi ko na kayang isulat yung proof. Kasi nagre-rely lang ako sa pagsunod dun sa pattern. Usually yung mga teachers, ano yan mga terror yung mga yan. So, papalitan nila ng konti yung given in such a way na medyo kailangan mong mag-isip. Pero if you are bounded on the pattern, or if you are restricted dun sa pattern na ginawa dun sa example, without and you're just doing it mechanically or replicating it mechanically, na hindi ka na nag-iisip, black box lang yon na ginagawa mo kung ano yung ginawa sa example, posibleng hindi mo makuha yung proof dun sa isang slightly different case. All right? This is the opportunity for us to really appreciate what is happening behind the scenes. So, sana ngayon, wag lang i-replicate yung ginagawa ko, all right? So try nating intindihin, bakit ganito yung proof? Bakit nagkaroon ka ng minimum between 1 and epsilon over 7, which comes out of the blue? Dati, okay, ganito yung ginawa ni sir. Nag-assume lang na less than 1 siya. Pero ngayon, hopefully with this understanding, you can choose, say, restricting x minus 3 to be less than, say, your favorite number, say 517. All right? So magkakaroon ka dito ng delta ay minimum ng 517 comma epsilon over something. All right? And that kind of creativity is something that you can only do if you really understand the concepts behind these things. All right, so I'm thinking, should I continue and start section 3.2 na? Oh, maybe one example. I'll insert it here. Malamang pagsisisihan ko tong additional example na to kasi sana simulan ko na yung 3.2. But anyway, okay. Let's try to prove that the limit of square root of x as x approaches 0 is equal to 0. Okay. Oh, by the way, missing from the proofs in the lecture notes is at least a mention that the number c is indeed the limit point of the given domain. All right? Or the domain under consideration. Requirement siya para makapag-usap tayo about limits. So basically, here, if you are operating under the Math 36 premises, hindi mo pwedeng ma-prove ito. Or you might say that this is wrong because the limit is not equal to 0 because the limit doesn't exist from the left, all right? Pero sa framework natin sa Math 155, nag-exist yung limit ng square root of x as x approaches 0 at yon ay equal kay 0, as we will see later. Okay. Here I will be a little bit more meticulous than before or than the lecture notes. Kailangan ko talagang i-justify na ito yung totoong limit. Okay. Now, first I'll make a mention that 0 is a limit point of the domain 0 to positive infinity of f of x equals square root of x. Okay. LC0, by our earlier discussion, is a limit point of the half closed, half open interval 0 to positive infinity. Sorry, hindi pala to half open, half closed. Erase yung sinabi ko kanina. Ito ay closed interval, 0 to positive infinity. All right. Yeah. Nung closed, itong closed set, 0 to positive infinity, limit point niya si 0. So it makes sense to talk about the limit of square root of x as x approaches 0. Okay? Now, we can do the PA. Gawin ko na lang yung PA sa scratch paper. Kunwari, scratch paper itong nasa gilid. Okay? So, PA. Now, we let epsilon be greater than 0, and then we want to look at f of x minus L, but this guy will just be this absolute value of square root of x minus 0, which is just square root of x. Okay, and then remember here, we will be assuming that absolute value of x minus c is between 0 and delta. So, ibig sabihin dito, gusto ko to, ang makukuha ko dyan ay absolute value of x is less than delta. Okay. Pero dahil ang usapan lang naman natin ay for positive x's, ang absolute value ng isang di pala positive x's, non-negative x's. Alam natin ang absolute value ng non-negative numbers ay yung sarili nila. So I can just drop the absolute value. So the delta inequality will tell us that x is less than delta. But since x is non-negative, all right, I can take the square root of both sides and get this guy. Okay, so implying niya yan, and I can do that because x is non-negative, all right? Pag non-negative yung mga numbers na nandun sa inequality, taking the square root of both sides will not affect the inequality, all right? So now from the delta inequality, we can deduce that absolute value of x is less than square root of delta. So what I'll do is, okay, so this guy is less than square root of delta. What I'll do is to force that this guy, okay, is less than epsilon. Or siguro pwede kong sabihin dito na force square root of delta to be less than epsilon. Okay? Para ma-force, in effect, yung absolute value ng f of x minus L is less than epsilon. Okay? But this will require delta to be less than epsilon squared. Again, I can do this because delta and epsilon are both positive numbers, right? Square root of delta and epsilon are both non-negative numbers. So, pag ini-square ko both sides of the inequality, nothing will change. All right? Kasi increasing yung x squared sa mga positive, mga positive x's. All right? So now what we will do is to choose delta to be smaller than or equal to epsilon squared. Lagay natin yan. So yun yung naging sagot dun sa PA. Tago ko na yung PA. So here, I can issue the challenge epsilon, then choose delta to be equal to epsilon squared. Okay. Then if the absolute value of x minus 0 is less than delta, then we are sure that, lagi ka dito mag-start, okay? Gusto mo mapalabas yung epsilon inequality. So here you'll have what? We'll have absolute value of x less than epsilon squared, okay? But x is equal to absolute value of x. So magiging ganito na lang yan. Kasi si x mo ay nandun lamang sa 0 to positive infinity. And then we can take the square root of both sides. Square root of x is less than epsilon squared. So this means that absolute value of f of x minus L is less than epsilon squared. Sorry, is less than epsilon na lang. Kasi nag-square root na nga pala ako dito. Okay. Medyo kakaiba pala yung presentation ko ng proof, no? Nag-start ako dito, tapos diretso kong napakita na totoo tong inequality na to. But note that every step of the way here, or all of the inequalities here, are previously established inequalities. So this is perfectly valid. But another way of writing the proof is to start with absolute value of f of x minus L. So this guy will be square root of x minus 0. Okay. So this will be square root of x. Okay. But square root of x is known to be what? This is known to be less than, okay, kasi mula dito makukuha natin ay x less than delta. So square root of x will be less than delta squared. So this will be less than delta squared. Pero ang delta, chinus natin to be epsilon squared. Baligtad pala, sorry. Square root of delta pala to dapat. Tapos ito ay epsilon squared sa loob ng square root. So magiging less than epsilon. So what you have is absolute value of f of x less than epsilon. End of proof. So indeed now we need to accept that that the limit of the square root of x as x approaches 0 ay equal kay 0. Kasi wala siyang na-violate dun or na-satisfy niya lahat ng kailangan dun sa preamble ng definition. Okay? So that is basically one of the things that mas kakaiba mula dun sa Math 36 versus Math 155. Dito mas generic yung pagtingin natin. And we're able to take a broader look at things because we know more. Okay? Kasi pinagdaanan natin yung sequences, dinefine natin yung limit points, all right? Yun yung kagandahan ng may prior knowledge. The more knowledge you gain, the broader your perspective on things are. And that is true in life in general, pero totoo rin siya sa math. Kasi sa Math 36, hindi natin to pwedeng gawin. Kasi wala tayong konsepto ng limit points. So napaka-kitted nung pagtingin natin dun sa limit ng functions sa Math 36. But since we gained new knowledge about limit points, ngayon sa Math 155, kaya nating i-consider yung mas generic na sense, mas generic classes of functions na kukunan natin ng limit. And that would basically be the theme for the remainder of the course. Titingnan lang natin through a wider lens yung mga konsepto na natutunan na natin sa Math 36. Starting next meeting, we'll be looking deeper at the concept of limits vis-a-vis the things that we have learned in the first 2 chapters of the course, all the way towards the end of the semester when we start talking about derivatives and integrals, but again, from a wider lens, the lens of the set of real numbers being a complete ordered field. And with all of the attached properties na nag-gain niya from being a complete ordered field. Okay? And I think it's exactly time. So do you guys have any questions, clarifications? Oh, just mark your calendars. We will have a homework that I will give on. Kailan nga ako nagbibigay ng homework? Nakalimutan ko na, tagal na ng last homework natin. I'll give a homework on Friday, okay? Tapos ang deadline niya ay Tuesday, next Tuesday. Is that okay? Alam niyo naman ako pag nagpapa-homework, maiksi lang, mga 1 question lang, worth 5 points. Probably it will be about proving limits of functions. So kindly put that on your calendar so you can plan ahead, okay? Para hindi matambakan, right? Bigay ko siya sa Friday. You can do it on Monday and then, or actually you can do it on Monday. It will take you less than an hour to finish it. Tapos Tuesday, right before midnight ulit yung submission, okay? So I guess you don't have any questions. I hope you got something new from today, though familiar yung mga topics. So yeah, let's meet again on Thursday. But until then, keep safe, everyone, and enjoy the rest of the day. Bye. Oh, mag-comment pala kayo. Comment nyo dun sa chat that I'll give you little extra credits for joining the class today. All right? So pag hindi kayo nag-comment, wala kayong extra credit. So doon ko lang kasi ibabase yung extra credit. All right? So I'll end the recording and I'll drop the call. Pero pwede pa rin naman kayo mag-comment kahit